Alright, hello everyone. Today we are going to find the minimum area to cover all ones, part 1 and 2. This was from the last weekly contest. This is straightforward and I was able to solve it during the contest, but the second part I was not able to solve it, but it's very interesting. I learned a lot after I solved it. So let's see. This is very straightforward. We are given one grid and we need to cover all the ones inside one rectangle such that the area is minimum, right? So in that case we just need to find the topmost I, the bottommost I, the leftmost j and the rightmost j, and that will be and we can calculate the area and that will be the answer, right? Because the maximum I, the minimum I, and the maximum j, minimum j, we can just, the maximum itself, the maximum and the minimum function is going to take care of the minimum area, right? This will cover both all the ones and the minimum area. Both the constraints are met using these functions. So we can just initialize with the extreme values of max, int max and int min. The respective indices, min j will be int min, this will be int max, and the other two values will be int min. This will be min max j and max I. Right, so now we can just do a single pass and update all the values. This will be the outer loop and this will be the inner loop, and g++, and we'll update all the four indices together. So min I will become the minimum of min I, comma, the ith index. Min j will be the leftmost index, so min j will be the minimum of min j, comma, j. And similarly the other two will be for the maximum, that is the bottommost and the rightmost. This will be max I, this will be max j, this will be max function, this will be max function, this will be max I, and this will be max j, right? And now that we have all the four index, then we can just find the side. Oh, actually I missed one thing, since we have to update only when we encounter a 1, right? My bad. That's the most important part. Let's keep this inside. And let's find the index. Also one thing we need to check, since if there is not a single one inside the grid, in that case this int max and int min will be present at this point as well. So we have to take care of that, and in the constraint it's given, I think, that there is at least one, so the values will be updated even if there is only a single one, so we don't have to worry about that case. But we need to add 1 to every side, because if there is only single index, single one, right, in the grid, in that case minimum I and the maximum I will be same, right? But still the answer should be 1, because there is one cell which is containing 1, right? So this is 1 as given in the example as well. So we'll just take max I minus min I plus 1 into max j minus min j plus 1, and this will be the answer. The time complexity will be O of 1, oh sorry, O of n cross n, and let's submit. Yeah, it works. Let's go to the next part, and also let's copy this because I'm going to use it there. So copy it. This is the copy. So this states that we are given 3 rectangles and we need to cover all the ones using these exactly 3 rectangles such that they are non-overlapping. But before we straight away jump into this problem of 3 rectangles, we can try to do for 1 rectangle, which we already did. Now that we have done it, it's the same thing as, this is scaled to three rectangles, right? But if we do it for 1, we have already done it. But what if we do it for 2? What are the 2 possibilities with 2 rectangles? I have drawn it here. These are the only 2 possibilities, right? I mean, of course, there can be this line can be present at any point in the grid, but this is the only possibility overall if we look at it, right? And this is the only other possibility for 2 rectangles. This line again can be anywhere. This line, I mean, the middle line can be again anywhere in the grid, but overall the structure will look like this. These are the only 2 possibilities, right? And if we need to find the minimum area using 2 rectangles, in that case we can just take this line and try all the possibilities, right? Brute force it, and similarly do the same thing here, brute force it. So in that case this will be O of n square, right? This will be O of n square, and with such a constraint it will work, and it will give us the minimum area. Every time we do it, for example, the line is suppose here, suppose here, I've ruined it, but see, suppose it's here. So in that case, whatever area this will give and whatever area this will give, I can just find it, right? But the most important thing is, how will we find this minimum area? We need to find the minimum area for 1 rectangle, right? And we have already solved it just before this point. We can use that. So we can use that first function for this one, for this one, for this one, for this one. So for all the 4 possibilities, we are going to use the first function. Similarly, now if we try to scale it for 3 problems, 3 rectangles. Let's take this back, and 3 rectangles. How many possibilities are we coming up with? We can just write on a pen and paper. I did that, and for convenience I have also drawn it here. It eventually will give 6 possibilities. And what are those 6 possibilities? We can have something like this, 1, 2, 3. We can have something like this, 1, 2, 3. Then we can have something like this. So again, here we need to do all the brute force of finding, like if this line was here and this line was suppose here. So in that case, we can just, for every box that we see here, we can just call the first function that we have already done for the part 1 of this problem, and we can get the minimum area. And then all the 3 areas that we get, we can just add it up and update the answer every time we change this line or this line, right? So that's it. That's how it's done. All the 3 possibilities will be, all the 6 possibilities for the 3 rectangles will be this. And then we can have verticals and then horizontals. Actually the question that is given is for the horizontal, the vertical one, the vertical possibility, right? Similarly, now if we try to solve for the four rectangles, in that case this problem will become very huge in terms of coding. Implementation will be a lot of code. In that case, I think that's not the right way to do it. But if we try on pen and paper, we can just do the same thing. Like I think there will be 12 possibilities if we go for four rectangles. One will be here, and I mean we can do it similarly. Again, we can have this 4 ways, this also 4 ways. We can have a lot of possibilities with 4 rectangles if given, but since this is only 6 possibilities, we can just implement every possibility by changing a little code of one of them, right? So here let's begin. I'll just copy paste the first function here. Let me just copy this function because we are going to use it anyway. Yeah, let's paste it here, but we have to change something here, right? Let's see what is that something. First I'll get the grid sizes, the row size and the column size, because we are going to use that very frequently. And column size will be this, right? After that we are going to have 3 areas, right? Because 3 rectangles, we have 3 boxes, so every box is going to have its own area. So 3 areas, you can just store it in something like int first, initialize it to 0, and third. And the answer, that will be initially maximum. So the first possibility, let's paste it here and then try to brute force it. Let me just comment it. We can just refer this and try to code it. So for the first possibility, we see that the row values and the column values are spanning from 0 till some point, right? But this point can have any index, because we are trying to brute force this. So we are traversing basically from the 0 index to m-1. And since for the first box we see that only the row is changing, right? The columns are fixed for the first box from 0 to n-1. So we can call this function with some values, because here we are traversing the entire grid, but we don't need to traverse the entire grid. We just need to traverse from 0 till I and the entire j, that will be the entire column. So here I can just update this function to something like start index, end index, start j and end j. And here instead of going with the grid sizes, I'll go with start I, and I'll just do it this way, that I'll send only the valid indexes here. So you can just do this equal here instead of less than. That will remove some confusion. So here this will be end j, sorry, this will be end I, and this will be start I. This will be start j. That's it. This will also be equal, and that's it. This will give me the value, but there's another problem, because I think, okay, there is at least 3 ones, but since we are brute forcing, right, we will eventually reach scenarios where we don't find a single one. In that case, we should not have these values initialized as int max. We just need to check if min I is equal to int max, or min j is equal to int min. So this is also max j equal to int min, and similarly min j, min I, sorry, max I, that's what I'm saying, max I equal to int min. If any of this is true, I just return the maximum possible area that can be possible. Can be possible. I can also return int max, but that will be a problem, because if I return int max for either of these 3 values and I eventually add something else, right, because we are going to add these 3 variables. So if I add something like int min int max to something like +2, that is going to overflow. So in that case, I will just return the maximum possible area, that can be 900. So I'll return 900 here, and now let's get the area for the first box. That will be minimum area of grid, the first or the 0th index, because I'm brute forcing it, so basically the entire thing, and the end index will be I, right, since this is the point I'm trying to find the minimum area, and the entire G, that will be n-1. So this is it, and this will give me something like first area, and for the second and the third area I am going to run another loop, because there's another line dividing these 2 areas, these 2 boxes. That is our G, and that will be G from 0 to n, C++, and this second box was running from 0 to J, so I will run from 0 to J for second area, second box, minimum area, grid, and this will run from I to the entire box, right? The start I and the end I will run from I+1 actually, because we're stopping here, and it will run till m-1, correct? And this will go from 0 to J, the Jth index. Similarly, the third area will be sorry, this will be second, this will be first, this will be third. Alright, so this will go from again I+1 to m-1 and G to the entire column. say n minus 1. So this will give me the third area, and every time I calculate the first, second and third area, I'll update it. Answer, comma, first plus second plus third. This is how I'll solve the first possibility. Now similarly, all the 6 possibilities can be solved. I'm not going to show you the 6 possibilities because it's very similar, so I'll just explain it with the code that I've already done. So that is this. So from second possibility, let me copy the code. For all the 6 possibilities, the code is very long. It seems long, right? But it's very, we just copy paste this snippet and just update the values, the indexes. So that's it. So I'll just copy paste it here. So for the second possibility, I am doing the same thing but with different indexes, and again the same goes for the other possibilities as well. So let's try to submit it. Also, I was using this variable. I'll update it. I'll update the first possibility and the original variable. So this one, two, and three. Let's see if this works. And then here's a same problem. Let's see if this works. It does. Yeah, it's pretty efficient. Thank you for watching.